Hi everyone. Today we're going to look at this lesson called Comparing Data Distributions. So let's take a look at it. In college basketball, some teams get most of their points from just one player, and other teams are more balanced in scoring. Consider the following facts about the scoring distributions for some NCAA Division I basketball teams. Each team has 12 players. So they have three schools here. First is Baylor. Baylor University, there are 6 players who each score 12 points per game, and there are 6 players who each score 0 points per game. At the University of Maryland, 1 player scores 58 points per game, 1 player scores 14 points per game, and the rest of the players scores 0 points per game. At Dartmouth, 4 players score 5 points per game, 4 players score 6 points per game, and 4 players score 7 points per game. Okay, and they're asking you some information. For instance, the mean number of points per game for players at Baylor is, sorry. So they're asking you what the mean is less than or greater than the mean points per game for players at Dartmouth, standard deviations, etc., etc. Okay, so I mean, you could do this by hand. Again, it's going to be a very tedious process. If you want to use the calculator, that's fine too. All right, but again, you're going to have to, I would imagine you're going to have to employ, probably the best bet is to use your calculator. So let's take a look at it here. I'm going to show you how to kind of work these problems using the calculator. All right, so let's first look at Baylor. Baylor has 6 players who each score 12 points per game and 6 players who score 0 points per game. So we're going to go into our stats feature, which is choice 2. And then we have our lists. So again, you can type in 6 12s here, right? So 12, 12, 12, 6 times, and then 0 6 times 2. Or you can do it a little bit more elegantly, and you can do this. Since 6 players score 12 points, I'm going to put 12 here like that. And then I'm going to put 6 in list 2. So basically, I'm going to say that 6 players, in other words, 12 points here. This list 1 represents the number of points, and list 2 represents the number of players. So in other words, list 2 represents the frequency of those players who scored 12 points, and that's 6. So 6 players score 12 points. So this is the frequency of the number of players who score 12 points. And likewise, 0 points were scored by 6 players as well. Okay, so 12 points were scored by 6, and 0 points were scored by 6. Okay, that's our Baylor. And now I'm going to do a calculation because we're going to need, let me see, we're going to need some information like mean, standard deviation, and median. So how do you calculate that? Well, we go into calc like that. And before we type any of this stuff in, we have to set our calculators so our calculators know that list 2 represents the frequency. In other words, the number of players who score that many points. So we go to set, and it says in one variable, the X list is list 1, right? So that's our variable. The number of points that are scored is in list 1. And the frequency of those points that were scored by players is going to be in list 2. So we have to change this 1 into 2. So we're going to go into list, and we're going to define 2 as being the frequency, the number of players who scored that many points. Enter. Oops, sorry. Missed on that. Should have, you have to scroll down there. There you go. Okay, and now it's list 2. Okay, so let's take a look. In list 1, we have our variable, which is the number of points. And in list 2 is the frequency, in other words, the number of players who scored that many points. Okay, so we're only working with one variable, so we don't have to worry about all this other stuff here. There's only one variable. That's the number of points in our table. Okay, so let's exit out now. And now that we have defined list 2 as the frequency for list 1, we can now click on one variable, because we only have one variable, that's number of points. And then we're going to get our statistics. All right, so X bar here represents our mean. So X bar is the mean. Okay, and then this is the sum of all of the X values. This is the sum of all the X values squared. Now sigma X, that's our standard deviation. Okay, standard deviation is basically a measure of how spread our data is, basically. Okay, so standard deviation is a measure of data spread. How spread out is our data? The bigger the number, the more spread out. The smaller the number, the more compact. Okay, there are 12 data points, right? Because there's 12 players. Let's keep scrolling down. See, we have our minimum value, our first quartile, we have our median, we have our third quartile, we have our maximum value, we have the modes, right? So we have all the information that we need. So I think we're going to need the mean. We're going to need the mean, and then we're going to need the median and the standard deviation. So for this first one, let me write it down here. Okay, so for Baylor, okay, our mean for Baylor was 6, I believe. Our standard deviation was, let me see again, 6 as well. And our median for Baylor was 6 again. Okay, so there's our information for Baylor. Baylor, everything was 6. Mean, standard deviation, and median. Okay, and we're going to do the same thing now for Maryland, and we're going to do it for Dartmouth. So let's do it now for Maryland. Okay, we're going to need the same information, right? Sigma and median. And then the same thing now for Dartmouth, right? Dartmouth. Mean, standard deviation. By the way, this is sigma, the Greek letter sigma, which represents standard deviation. Okay, so let's go back to our calculators and redo this now for Maryland. So we're going to go and we're going to exit, and we're going to exit again. And now let's delete all this. Delete, delete, over, delete, delete. Okay, and plug in all the values now. And Maryland, one player scores 58 points, one player is 14, and the rest of the players is 0. So here, 58, right? And that's scored by one player. So we have a superstar on the team, right? And then one player still scores 14, and that's 1. And then, what is this? We have the rest of the players scoring 0. So there's 12 members, so 10 players scored 0. All right? And then let's do our calculation again. Again, these are the number of points, and these are the number of players who scored those numbers of points. So calc, make sure our setting is the same. Yes, our setting is the same. Let's do one var, and let's write that information in. So again, we have mean is 6, and our standard deviation here is now 16 point, what is it, 16.1? So let's average, let's round it to 16. And then what's our median for Maryland? Is 0. Okay. And then finally, let's do the same thing for Dartmouth. Okay, so exit. Let's erase all that stuff. Okay, erase, erase, delete, 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 delete. And at Dartmouth, we have 4 players scoring 5 points. We got 4 players scoring 5 points. We got 4 players scoring 6 points. And then we have 4 players scoring 7 points. Oops, sorry. Wrong one. Okay, so we have 7 points that were scored by 4 players. So this is a pretty evenly rounded team, right? And let's do our calculation. So 4 players scored 5, 4 scored 6, and 4 scored 7. Calc, and then single variable, and there's our information for Dartmouth, right? We have 6.8 and 6. So we have 6, 0.8, and then 6, correct? So I think we have enough information to answer this question, right? So it says here the mean number of points per game for players at Baylor, that's 6, is compared to Dartmouth. And it looks like Dartmouth is a 6 as well. So how do we, no, we can't do this. We gotta do this now, right? So they're equal. 6 and 6, right? And now let's look at it again. Standard deviation for Dartmouth and Maryland. For Dartmouth, for players at Dartmouth is 0.8, is significantly less than the standard deviation for Maryland, right? So less, much less, much less, all right? And then finally, let's compare the medians for Baylor and Maryland. Baylor, Maryland, they are, so the median for Baylor is 6, the median for Maryland is 0. So the median for the players at Baylor is greater than the median number of points for Maryland. Greater, right? So it's greater. And that is all. And that is correct. Okay, guys? All right. So again, this is the same idea, but now we're using these graphical representations, right? These graphs. We have the box plot. We have the dot plot, right? So let's see if we can answer this question. Now, Maddie wanted to see how lung capacity varies among endurance athletes at her high school. She sampled athletes on the crew and cross-country teams and recorded how many seconds each athlete was able to hold his or her breath. Her data is shown in the 2 plots. So we have, this is for the cross-country team. So we see the median here, we see the quartiles, first and third, and the minimum max, right? And then we have the crew. All right, and again, the same idea. So we're looking at the medians. So here in the medians, it's clear that the cross-country team has about a median value of about 75, but the crew, it's not so clear, correct? So if you want to find the median here, you have to kind of see what the middle value is going to be, right? So if we do the, if we kind of count up how many there are, it looks like the median is going to be somewhere, the middle value, if we count up here, it's going to be somewhere in here, right? Which is again going to be, doesn't matter, it's still going to be higher than the crew, right? Still going to be higher than the cross country. So the median value for crew is going to be somewhere in here, which is again going to be higher than crew. So we know that the median, it says here, the crew has a greater median, right? And what about a standard deviation? Standard deviation measures the spread, correct? So our spread here is pretty wide on the cross-country team. It goes from almost 30 to almost 150. Standard deviation, look how compact the data here is. So again, standard deviation of the crew is going to be less than the standard deviation for the cross-country. Or the cross-country team is going to have a greater standard deviation, right? So it looks like the cross-country team has a greater standard deviation because, again, standard deviation is a measure of spread. It's a measure of the spread of data. So let's check, and that is correct. Okay, guys?